Hello friends, in this session we will discuss your previous year Coal India Limited paper. Right, we will solve this paper in this video and we'll see the theory related to all these questions. So the first question in your previous year is that in a rolling process the roll separation force can be reduced by, right? Rolling process is your topic in your production engineering. So the question says that how you can reduce the roll separation force. So options are providing the backup roll. If you give the backup roll, then the area of contact with the workpiece increases and your separation force will increase. Next is increasing the friction between roll and workpiece. Separation force is basically because of friction only, and if you increase the friction, then that roll separation force will increase. Increasing the roll diameter will not help, because if you increase the roll diameter, then also the surface contact with the workpiece will increase, so it will not help. Then the option will be the reducing your roll diameter. If you reduce the roll diameter, then the surface in contact will reduce and roll separation force will reduce. So the option is D. Next question is, what happens to the liquid level when a small diameter tube is inserted into the liquid whose contact angle is 125 degree? Right, this is a question on your capillarity of your fluid mechanics, and you know that the formula of capillarity will be or capillarity rise or capillarity fall will be 4 sigma cos theta divided by rho GD, right? So if the contact angle is greater than 90 degree, you know that in this case your liquid level will fall. If the angle of contact is less than 90 degree, then liquid level in the tube will increase. If the angle is more than 90 degree, then your liquid level will fall. So the option will be A, that is liquid level in the tube will fall. Next question is the spring rate or stiffness that of a spring is given by, where W is given as load and delta is given as deflection of spring. You know that the load, that the spring stiffness, the meaning of stiffness is that how much load is required to make 1 mm elongation or 1 mm deformation in the spring. So the spring constant will be equal to load upon deflection, that is W upon delta. So the option is D for this third question. Now the next question is, if V1 and V2 are the initial velocities of the two bodies making direct collision, and if U1 and U2 are their respective velocities after collision, then what is the coefficient of restitution given by? This is a question of your engineering mechanics when two bodies are colliding. So the coefficient of restitution will be given by your final velocities divided by initial velocities. So the final velocities are the ratio of the difference of final velocities are U1 minus U2 divided by the initial velocities, that is V2 minus V1. So answer is A for this fourth question. The next question is electron beam machining can be carried out in. The options are vacuum, water, open air and pressurized air. In that electron beam machining, what we are using a beam of electron to do the machining, to remove the material on the workpiece or to make some contour on the workpiece. So for that we need the vacuum, so that the charge of that electron will not reduce, and for that your vacuum is needed, no air or not water. If you use the water, then water will reduce the energy of the electron. Next is thorough vibration. Next question is through vibration cannot be completely eliminated. It can be suppressed to a greater extent using, as you know, we are using the damper to reduce the vibrations. Damper force is directly proportional to velocity, as you know, and with the help of damper you can reduce the vibration in any machine or in any object. And you know that there are 3 types of vibrations, that is damped vibration, over damped vibration, under damped vibrations. So with the help of your damper we can reduce the vibrations. Next question is, a cantilever beam carries a concentrated load W at its free end, then its shear force diagram will be, right? Now we have a cantilever beam, at the free end we have a concentrated load, so we have to find what is the shear force diagram. As you know that if you have only one shear force at a free end and there is no load in between the span, so the load at each and every section on that cantilever beam will be the shear force, that is W. So in that case your shear force diagram will be a straight line of height W. So the option will be your this A option will be there. It is of your same height, that constant shear force will be there along your length. And if the shear force is constant, if they ask in that what is the bending moment, then bending moment will be your straight line, inclined line, because the bending moment now will be directly proportional to the distance from the free end. Or if you find out that at any section the bending moment will be W into X, so you will get a straight line. So just remember one thing while you have to find what is the shear force and bending moment. So bending moment is one order higher than the shear force, and shear force is one order higher than the load. Right? If the shear force is constant, then bending moment will vary linearly. If the shear force is linear, then bending moment will vary parabolically. So on this basis, you will easy to find out what is the shear force and bending moment diagram for different kind of beams. Next question is that dash is the capacity of the material to absorb energy when it is elastically deformed, and then upon unloading to have this energy recovered. Right, we already know the concept of strain energy. Strain energy is the energy absorption capacity of a body when it is under some external load. If you apply some load on it, then the energy which is stored in that body is known as strain energy. And strain energy of two types, one is resilience, one is toughness. So resilience is the strain energy stored in the body up to elastic limit. If you apply the load, that load is within the elastic limit, then energy stored in that is resilience. And when you remove the load, the strain energy will be given back to you. And so the strain energy or the resilience is the recoverable energy. So the option will be resilience. Toughness is not the option, because toughness is the strain energy when it is that load is in the plastic region. When you will go beyond the elastic limit, then the strain energy stored is the toughness. So the option will be resilience. The next question is here, which of the following is true for the self-locking screw? Right. That we have to find out what is the self-locking screw. Self-locking screw means if you apply a load on the screw or a compressive load on the screw, that lock will not move, that nut will not rotate. So for that, your condition will be that the coefficient of friction is equal or greater than the tangent of helix angle. Right? That mu will be greater than or equal to tangent alpha. That is the condition for the self-locking screw. If mu is less than your tangent alpha, then your screw is not self-locking. Then if you apply a load, for example, if I say that screw jack, you have that screw jack on which is used for that loading and unloading your vehicle, the automobile, right? If I apply a force on that nut, then that screw jack will come above or it will go down. But if I apply that if you remove the load, that only the vehicle load is there on that jack, that jack is not moving now, right? Because that screw jack is a self-locking screw. So for that, your coefficient of friction will be greater than or equal to tangent of alpha. Next is, which force is acting on the core when metal is poured into the mold cavity? Why core is needed? Core is needed. This is a question on your production engineering for the casting subject. Core is needed to make any hollow thing inside your casting. If you want to make some hollow tube or some hollow area inside your casting, for that core is needed. So if you pour some metal on the core, then that core is completely submerged into that metal and a buoyancy force will be acting on that core. Right, so the option will be your buoyancy force when the molten metal is poured inside the cavity. Next is in natural convection heat transfer, your Nusselt number is a function of, right? We know that in natural convection, we have that the Nusselt number is a function of your Prandtl number and Rayleigh number. That is a theory question. Directly you can solve it, that Nusselt number is a function of Prandtl number and Rayleigh number. Next question is on your strength of material, that a thin cylindrical pressure vessel. Please mention that here it is given thin cylindrical pressure vessel. The internal diameter is 500 mm, is subjected to a internal pressure of 2 Newton per meter per mm square. That is 2 megapascal. What is the hoop stress if the thickness of the vessel is 20 mm? right? Hoop stress is the circumferential stress that is acting on that cylindrical pressure vessel, and formula for the hoop stress, as you know, in the cylindrical pressure vessel is PD upon 2T, right? P is the pressure inside the cylinder, D is the diameter, divided by 2 into thickness, right? So, and if it is asking that what is the longitudinal stress, then longitudinal stress will be PD upon 4T. And if the question comes this year on spherical pressure vessel, then in the spherical pressure vessel, the hoop stress and the longitudinal stress will be of same unit, that is your PD upon 4T. So in this question, you will use the formula PD upon 2T, right? P is your 2, diameter is 500, divided by 2 into 20, that is 40. So you will say that answer is your 25 Newton per mm square. This is the hoop stress which is acting on this thin cylindrical pressure vessel. Next is in the turning operation, the typical ratio of heat generated in the chip, tool and workpiece is in the order of, right? As you know, when a single point cutting tool is doing this turning operation, then the maximum amount of heat which is generated because of that friction, because of that cutting, will go to the chips, and then it will go to the tool, and very less amount of heat will go to the workpiece. So the ratio will be 7:20:10. Maximum amount of heat will be taken by your chips. If the maximum amount of heat is taken by the tool or your workpiece, then obviously there are some stresses, thermal stresses develop inside the tool or inside the workpiece. So maximum amount of heat should be taken by the chips, because chips will be a waste for us. So the ratio will be 7:20:10. Next is, in the flat belt drive, the condition of maximum power transmission is given by, where T is the maximum tension and TC is the centrifugal tension in the belt. This is a question in your machine design from belt and rope drive. So here the option will be that the maximum tension will be equal to 3 times the centrifugal tension. Then only you will get the maximum power transmission capacity in the flat belt drive. Now the next question is, in the electric discharge machining, the temperature produced by the spark between tool and workpiece will be, while machining be in the order of, right? In the electron discharge machining, what we are doing is, we are using the discharge of that electron to produce the spark and to melt the material in which we have to remove in order to do the machining process. So the temperature is too high in the electron discharge machining. So the answer would be your 10,000 degrees Celsius. The next question is, what is the maximum possible theoretical efficiency of a heat engine operating with a hot reservoir of gases at 2127 degrees Celsius, while the cooling water is available at 27 degrees Celsius. Temperature limits are given, high temperature, low temperature limits are given. You want to find what is the maximum possible thermal efficiency. You know that from the thermodynamics concept that in between some temperature limits, the maximum efficiency is of that of reversible cycle, and the reversible cycle efficiency will be 1 minus T2 upon T1. So in this, T2 is your 227 plus 273 is equal to 300 Kelvin, and T1 is your 2127 plus 273. We convert the temperature in Kelvin and put in the formula 1 minus T2 upon T1, then your answer will be 87.5%. Right? He is asking the maximum efficiency, and maximum efficiency is of a reversible cycle. Next is, what is the number of cycles completed per second for a 4-stroke diesel engine running at 6000 RPM? Right? He is asking how many number of cycles completed per second. Per second he is asking, and the RPM is given is your 6000 RPM, that is revolution per minute. Now first of all convert it into revolution per second. So if I divide this by 60, it will be your 100 revolution per second. In a 4-stroke engine, you know that out of our 2 revolutions, 1 cycle will be completed. In 2 revolutions, if 1 cycle is completed, then out of 100 revolutions, your 50 cycles will be completed. So your answer will be 50. The next question is, the tolerance for hall and the shaft assembly having a nominal size of 40 mm are as follows, right? You will be given the nominal size or the tolerance level of hole and size For the hole it is 40 plus 0.06 plus 0.02, and the shaft is your 40 minus 0.06 and minus 0.08 mm. Tolerance level are given, your high tolerance and your low tolerance level. We have to determine the mml of hole. What is the mml? Mml is the maximum metal your limit. The maximum metal limit for the hole is this high tolerance, that is upper limit of the tolerance. Then upper limit of the tolerance will be your the 40.02. So the answer will be your 40.02 for the hole. It is asking mml, right? Next is the time period of the pendulum for the length L which is placed under the gravitational acceleration G is given by, right? A pendulum is given and it is your oscillating with in the consideration of your gravity force. Then the direct formula is there, that time period is equal to 2 pi under root L over G. So the formula will be, the option will be D. Next is your, what is the process involves planning the production output levels of major product lines produced by the firm, right? Which is of the following involves planning the production output level for major product lines produced by the firm? This is a question in your industrial engineering in your PPC, that is planning, production and control. So the process which involves planning will be the aggregate production planning. This is a theoretical question, right? Straight away you can solve it. The next question is the angular motion of a disc is defined by the relation theta is given, that is 3t plus t square, where theta is in radians, and t is in seconds. What will be the angular position after 2 seconds? So he is asking what is the angular position after 2 seconds. So if theta is given 3t plus t square, if I put t is equal to 2, then you will get that 3t, that is 6 plus 2 square, it is t cube, right? So it is 8. So 8 plus 6 is 14. So the answer will be 14 radians. He is asking angular position, not the velocity, right? Next question is, in the Mohr circle, if sigma 1 and sigma 2 are the principal stresses acting at a point on the component, the maximum shear stress is given by. As you all know that if sigma 1 and sigma 2 are the principal stresses in a Mohr circle or in the combined stresses and strain, then the in plane tau max will be equal to your mod of sigma 1 minus sigma 2 by 2, right? It is the in plane tau max. Here it is saying what is the maximum shear stress tau max. Only option available is your sigma 1 minus sigma 2 by 2. If students are confused with that, whether we have to find the absolute tau max or your in plane tau max, but after seeing this option, it is very clear that he is asking about in plane tau max. So you have to choose sigma 1 minus sigma 2 by 2. It is and you all know that the radius of the Mohr circle will give you, if I say that the radius of the Mohr circle will give you the maximum shear stress, and the center of the Mohr circle, x coordinate of the center of the Mohr circle will give you the shear stress, or will give you the normal stress on the tau max planes, right? If we will see some of the theory here, that in the principal planes are those planes where your normal stresses are maximum and there is no shear stress. And there is one more example, that the maximum shear stress planes are those planes at which your shear stress is maximum, but at that plane your normal stress will not be 0. So the normal stress at the maximum shear stress plane will be given by the x coordinate of the center of your Mohr circle. You just remember this. Next question is, this is of gyroscope. A disc with mass moment of inertia I and a angular velocity omega radian per second is spinning about the axis of spin. The angular velocity of that axis of spin is omega p. Then what will be the gyroscopic effect? Right, what will causing the precession will be. You want to find out what will be the gyroscopic effect. You already know that the direct formula for gyroscopic effect is your moment of inertia of the disc into the angular velocity of the disc into the angular velocity of your that axis. That axis is also rotating. Gyroscope, in the gyroscope what we have, that rotating disc, the axis of the rotating disc is also rotating about some other plane. So in that case, the gyroscopic effect will be your I into omega p. So the option will be B. In the next case, we have How many elements are present in tool signature of a single point cutting tool? Right, how many tool signature? You all know there are 7 tool signature in the single point cutting tool. Your side rake angle, back rake angle, side cutting edge angle, end cutting edge angle, side relief angle, end relief angle, and the nose radius. These 7 are your tool signature. You must remember this. So the answer would be 7. Next is a steady incompressible flow is given by the x direction velocity. U is the x component of velocity, which is x square plus y square, and nu is the y component of velocity, that is equal to zxy. So he is asking what is the convective acceleration along the x direction at the point 1, 1. The point is 1, 1. We have to find what is the convective acceleration in the x direction. So you know that there are 2 types of accelerations. One is the convective acceleration, one is the local acceleration. If we will see what is the formula, then the formula for your convective acceleration or the total acceleration will be, if I talk about the formula in the x direction, it will be u into del u by del x plus u into plus nu into del u by del y plus omega into del u by del z plus del u by del t. Right, this del u by del t is the local acceleration. Convective acceleration is the acceleration in the space coordinates when we are talking about the space coordinates. So if you want to find out, so just differentiate that del u with respect to x and then with respect to y and put it in the formula, you will get the answer. Right, convective acceleration only he wants, not the local acceleration. Next is, in which of the following process metal molds are used? Where we are using the metal molds? So metal molds are used in the die casting. In the sand casting, sand molds are used for pouring the molten metal in the casting, and in the investment casting, wax mold is using, or the sand mold with the wax pattern we are using. So the option is the die casting, in which the mold in the form of die we are using. So die is made up of metal. So the answer is your die casting. Next is, a car starting from rest attains a maximum speed 100 km per hour in 20 seconds. So the initial velocity of this car is 0. Final velocity is your 100 km per hour in 20 seconds. Just convert this 100 km per hour in seconds. Right, in meter per second you just convert it, and what will be its acceleration, assuming it is uniform. Right, it is uniform acceleration. If the acceleration is uniform, we can directly write the Newton's law of motion. The Newton's law of motion equation is where we can use v is equal to u plus at. V is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. Here final velocity is 100 km per hour. We will convert it into meter per second. U is 0, initial velocity, time is 20 seconds. So from there you will get your acceleration. Just simple calculation, you can easily prove it. Next is, which of the following locating device is used to locate the cylindrical job? Right, when we are using this question is from jigs and fixture of your production engineering. Right, when you are doing some work on the or turning or some work on the cylindrical job, then which of these following devices is used to locate that cylindrical job? So cylindrical job can be located in a V block. Right, V block is like this. You could put a cylinder here, so it will be useful for your locating the cylindrical job. Next is, the work transfer per unit mass for steady flow process with reversible adiabatic compression is. Right, he is asking what is the work transfer for a steady flow process. Steady flow process means that the system is a open system, not a closed system. So the open system work will be integration of VdP, that is the option B. That integration of PdV will not be an option, because the integration of PdV is a closed system work, not a open system work. He is asking steady flow. Steady flow means it is a open system. So the answer will be integration VdP. The next question is, a heat engine which receives 80 kJ of heat at 100 degrees Celsius and rejects 70 kJ of heat to the ambient at 30 degrees Celsius is to be designed. The thermal efficiency of this heat engine is. Now you can say that in this question you have temperature limits and heat rejection also, heat transfers also. He is asking the thermal efficiency of heat engine, not the maximum thermal efficiency. So don't use the formula of efficiency, that is 1 minus T2 upon T1. That is only applicable for the reversible cycles. It is not given that here that this heat engine is a reversible cycle. So the efficiency will be your 1 minus heat rejected upon heat supply. That means your heat rejected is 70, heat supplies is 80. So this will be your answer. Now next question is, which of the following is not an input for material requirement planning, right? For material requirement planning, which is not the input. So if you want to see that, the option is master production schedule. Master production schedule will give you the amount of quantity which is required to do an assembly, right? Purchase order is when you place an order for the inventory. Bills of material and inventory record file. So for this material requirement planning, you won't need that purchase order, that when you place the order, when your order will come, that is not required for the material requirement planning. Next is here, if U and V represents the velocity components in X and Y direction of a two-dimensional potential flow, then del U by del X is equal to, this is a question from Cauchy-Riemann's equation. So in that case, their del U by del X will be equal to minus of del Nu by del Y. This is a direct question, direct formula for your stream function and potential function. Now if we can say, see, this is saying that if U and V represent the velocity component in X and Y direction of a two-dimensional potential flow, then your del U by del X is equal to minus of del Nu by del Y, because this is a potential flow question. Next is here, which of the following is used as a dielectric medium in electric discharge machining? So the answer will be kerosene, right? Kerosene is used as a dielectric medium. In the Euler's formula, which is used in your columns and strut in strength of material, the ratio of effective length of the column to the least radius of gyration of the cross section is known as slenderness ratio, right? Slenderness ratio is effective length upon radius of gyration. This is a direct formula based question, direct theory based question. Next is, which of the following are provided in the mold so as to increase the heat extraction capacity of the sand molding, right? To increase the heat capacity, to the heat extraction capacity, we are using the chills. Core are using to make the hollow that molds, and chills are used to increase the heat extraction capacity to make the solidification time uniform. So that's why chills are using. Next is the principle most commonly followed for locating workpiece in a fixture is 3-to-1 principle, that 3 pin on one plane, 2 pin on one perpendicular plane and 1 pin on other perpendicular plane. So that is the answer is A, that is 3-to-1 principle, right? This all we know. Next is, an eye bolt is to be used for lifting a load of 70 kilonewton and tensile stress is not to exceed 100 megapascal. That is the maximum limit of tensile stress is given 100 megapascal. The core diameter of the bolt will be given as your 2800 upon pi, your under root of 2800 upon pi. This is a direct formula based question on your eye bolt. You can directly solve it by putting the value in the formula. Next question is, a shaft with torsional stiffness is given, that is Q, has a disk mass moment of inertia I attached at end, then the natural frequency will be. What is the natural frequency? Natural frequency will be equal to 1 upon your you can say the time period of oscillations or a time period of vibration will be your 2 pi under root K by M, right? You know that. So from there you can easily find your natural frequency of the free torsional vibration. When a spring and mass system is attached, then the frequency will be under root K by M, and if that is the angular frequency under root K by M, and if the torsional stiffness is there or torsional vibration is there, then it will be under root torsional stiffness upon, instead of mass it will be moment of inertia. If a particle is in static equilibrium, then the work done by the system of forces acting on that particle is 0, right? If that particle is in static equilibrium means there are net force will be 0, so there should not be any work done on that particle. Now it is saying that the natural frequency of a passenger car whose weight is W Newton and whose suspension has a combined stiffness of K is given by, right? This is a question on your theory of machine, vibration question, that natural frequency we have to find. The natural frequency will be under root K by M. You know this formula. So the option is A, K is the stiffness, M is the mass of that passenger body, right? This is the natural frequency. Next is the position of a particle in the rectilinear motion is given by the equation. You are giving the position vector, that is x is equal to t cube minus 2t square plus 10t minus 4, where x is in meters and t is in seconds. So what will be the velocity? You know what is the velocity? Velocity is the dx by dt, differentiation of displacement with respect to time. So if you put x dx by dt, it will be your 3t square minus 4t plus 10 minus 4 differentiation is 0. So in that case this will be the velocity, right? And put the value of your time, you will get the velocity.